Let's take a look back at what we learned in Chapter 3. We started in Section 3.1 with quadratic functions, and mostly what we wanted to do was graph a quadratic. In order to do this, we needed to find the intercepts. Find y-intercept, find x-intercepts. And we already were familiar with these ideas from previous chapters, from previous work. The new idea was to find a vertex. And we had two ways to do that. One was to use vertex form. And the other was to use a formula. X equals negative b over 2a. We also found an axis of symmetry. And then we put all that together to make the graph. And it would be good to remember that we had two ways to look at the formula for a quadratic. So standard form says y equals ax squared plus bx plus c. And then the new form, we saw standard form back in chapter 1 when we solved quadratic equations. Vertex form was new in section 3.1, and that says y equals a times x minus h squared plus k, which gives us a vertex at h comma k. Okay, let's go on to section 3.2. 3.2, we introduced synthetic division, and the goal was to divide two polynomials. And we had several ways to write our answer. You know, the basic idea is to divide a function f of x by another function, but the function in the denominator is just x minus k. The numerator, the f of x, could be degree 2 or 3 or 4 or whatever you like. And then we said that the result can be written as q of x, the quotient, plus the remainder divided by the divisor. So this was the first way to look at synthetic division. And then the second way was called the division algorithm. And the division algorithm tells us that we can rewrite the function, the polynomial function f of x, as x minus k times q of x plus r. And the really nice thing about this is that if r is equal to 0, then x minus k and q of x are factors. And so we are factoring the polynomial. We're factoring f of x. And so then that becomes more important in just a minute, and then on into the next section. So the third way to think about synthetic division was to find f of k, and we know that f of k is just the remainder from the synthetic division. And then finally we asked, is k a zero of f of x? And so k is a zero means that k is a zero means x minus k is a factor means f of k is equal to 0. And we can put a double arrow on these implications to say that that each statement implies the other two. So this leads right into section 3.3. We want to find the zeros of a polynomial. So again, so what is a zero? A zero is a value of x that makes y equal to 0. We probably ought to write that definition. A zero is a value of x that makes y equal to 0. Well, and you already heard that before. Isn't that just an x-intercept? A 0 is just an x-intercept. And I'm going to put almost here to remind you the one small difference between a 0 and an x-intercept. And that is that an x-intercept has to be a real number and a 0 does not. A 0 can be a non-real number. So just like when we were solving quadratic equations way back in chapter 1, sometimes the solutions were zeros. Sometimes the solutions were real, and so then those are x-intercepts on the graph, and sometimes they're not real, and then of course they're not x-intercepts, they don't show up on the graph. Okay, and so if you want to find the zeros of a polynomial, then there are a few tricks in there. So let's see here. To find zeros, let's just have a little example here. And this is, we won't go through all the details of the example, but we'll lay out a few highlights. And this is actually an example that we worked in one of the videos in section 3.3, so you can go back and watch that again. So find the zeros of f of x equals x cubed minus 7x minus 6. And you know what? This video might not be in section 3.3. It might be over in section 3.4. I don't remember, but you'll find it. Okay, so if you want to find the zeros of this function, basically you're saying find the x-intercepts, and if they happen to be non-real numbers, that's fine. We still want to know those as well. So so this just means that we're going to set y equal to 0 and solve for x. And so that just means we're going to solve f of x equal to 0. And for this particular example, we're saying x cubed minus 7x minus 6 is equal to 0. And of course, we solved equations similar to this in chapter 1, but the big difference was in chapter 1, the highest exponent was always 2. It was always a quadratic equation we solved. Now we're solving a higher degree polynomial equation. And so how do you do this? Here, let's put that in red for emphasis. And so the answer is a familiar one. It's the same thing that we learned in chapter 1. It's to factor. Factor the polynomial. How do you do that? You find possible rational zeros. And then you use synthetic division to find a zero and to factor f of x and to factor the polynomial. There were a couple other details in section 3.3. There was the conjugate zeros theorem, which you can look back at, and there was another problem, which was given the zeros, find the function that has those zeros. So you can look back at that. That's near the end of section 3.3. Okay, in section 3.4, we want to graph a polynomial. So for example, we want to be able to graph x cubed minus 7x minus 6. Here, let's write that out. And the more I think about it, I'm pretty sure that this function, that the video for this function is actually in section 3.4. Okay, so how do we graph polynomial? Well, it's going to be similar to what we did for the quadratic function back in section 3.1. We're going to find the y-intercept and the x-intercepts. To find the y-intercept, set x equal to 0. To find the x-intercepts, go through this process that we studied in section 3.3. So find the y-intercept, find the x-intercepts, describe the behavior at each of the x-intercepts. So the behavior at each x-intercept. And the end behavior. So let's see here. Let's number these off. So this is, if we want to make the graph, we're going to need a y-intercept. We're going to need the x-intercepts. We're going to need the behavior at the x-intercepts. We need the end behavior. And one more thing, which was a sign diagram. And actually, we said the sign diagram was optional. we said that if if the first four parts here are good, then the sign diagram is just a way for us to check our work and make sure everything fits together. There was one other thing in section 3.4, and that was to sketch transformations of basic function. And I won't write that here, but you should look at that as well. Okay, and then we're on to the last section, section 3.5. We try to graph rational functions. So remember, a rational function is a ratio of two polynomials. And so we had the big news, the new thing was it was to find asymptotes, was to be able to find horizontal and vertical asymptotes. And there are a few procedures in there. There are a few rules in there that you need to make sure that you're clear about. If you're going to graph a rational function, you're going to get the horizontal and vertical asymptotes. You're also going to get the x and y intercepts. So we keep talking about some of the same stuff over and over again, right? So we talked about x and y intercepts in section 3.1, 3.4, and 3.5, and really section 3.2 and 3.3 together was about finding x-intercepts. Okay, if you have horizontal and vertical asymptotes and you have x and y intercepts, you need a sign diagram. Remember, that's a funny looking D, isn't it? Let me see if I can fix that. Okay, so we need a sign diagram. There was one other little detail we needed to know. Does the function cross its horizontal asymptote? Function cross its horizontal asymptote. Or if the function has an oblique asymptote, does it cross that? And so we solved an equation in order to figure that out. And then we can put all of that together to sketch the graph. What else? Oh, there were two new basic functions. Y equals 1 over x and y equals 1 over x squared. You should know their graph. You should know their graphs, and you should know how to graph transformations of those graphs. You should also know the asymptotes and intercepts and domain and range for those graphs. I think that's about it for chapter 3.